Okay, this is the test video I made showing a robot running around the floor there on the right in a window with that green circle around it, which is showing that the computer is tracking its position, and on the left window is a Scratch program that's receiving information from the program on the right. So the program on the right, that window that says tracking, is running on a little netbook with a video camera pointing down at the floor watching the robot, and I'm just seeing into it so you can see what's going on. And the one on the left here is the actual Scratch program that's running on that robot, running Scratch GPIO. So basically the tracking computer on the right there is finding the yellow ball, finding the orange ball as well, and from that it knows the position of the robot. And the fact there's two balls there, a yellow and an orange one, means it can work out which way the robot's pointing because they're aligned in the direction the robot is going. So that's great. We can get the X and Y, and we can get the direction from just using OpenCV and the program on the right to track the robot. And that information is being fed over to the program on the left using MQTT, which is my favourite message transport system. So it makes it very easy to send messages between programs running on different computers, or same programming, two programs running on the same computer, without having to get all geeky. And there's some very simple libraries to use in lots and lots of languages. All this is programmed in Python, and I just love it. So that's how it's done. The computer on the right, the tracking computer, is sending positional information over to the one on the left. What's actually sending, it's not actually sending the position, it's sending the radial distance, the distance from the blue ball to the robot there. The blue ball is just in the picture, just to give us a reference to where the centre of the picture is, by the way, and to prove that the robot can go around it without knocking it over. So it's been sent the radial distance, it's also been sent the direction of the robot, and it's also being sent the bearing of the robot from the centre of the picture there. And therefore the robot, if you look at the Scratch program, it's very simple. It's got one bit of code at the beginning which just makes the robot move forward, but if the robot gets further than 90 away from the centre, then it goes into a turning mode where it tries and turns back in, and then it goes off again. So if we're watching it now, it's heading forward, the distance is 79, 78, 81, 83, 86, 89, 94. Now it's 94, and the robot is now turning, and it's turning till it's what I would call slightly towed in. So it goes past the tangent a little bit and then goes back to moving forward again. And that's quite a successful algorithm for navigating around an object in the middle of the screen. And now it's gone 93, so it's now turning. Basically it turns until it's 10 degrees past the tangential point, and then it starts going forward again. So there you are. Sorry you can't see the code on the left here on this screen, but you can see it in the blog because I've pasted a picture up there so you can see the whole of the Scratch code. And all of the main code is up on GitHub for the tracking computer, although it's very messy, very bodgy, and got no explanation. But hopefully I'll improve upon that, because I want to make that tracking program available to everybody that runs robot events or just teachers in schools. So I want to make it very simple and user friendly, and I've got a few ideas on how to do that. Anyway, so thank you very much for watching. Okay, this is the test video I made showing a robot running around the floor there on the right in a window.